Hi everyone, this is Sandeep Sharma, Electron X here, and welcome to my new video in which I have explained about Raspberry Pi and its components. This video is actually one of many videos that I will be posting in upcoming weeks. Basically, it's the first video of the playlist. And at the end of this playlist, there will be a video of practical project implemented using Raspberry Pi. Alright, let's begin. So what do you think Raspberry Pi is? Well, obviously it's not this. Here is how a Raspberry Pi board looks like. There are input ports, there are output ports, and many slots for connecting peripherals. We are going to discuss about the hardware components on one of the Raspberry Pi board, but here are other topics that will make up this video. After a brief intro of Raspberry Pi, we will get to know where all is a Raspberry Pi board used. We will see the models that Raspberry Pi Foundation has released so far and what are single board computers or SBCs. After all this, we will learn about different hardware components on a Raspberry Pi board. Moving to a brief overview of Raspberry Pi, it's a low-cost, fully functional computer with a size comparable to a credit card. That's really small. One interesting fact is that the name Raspberry Pi was chosen with raspberry because of the tradition of naming early computer companies after fruit, just like Apple. And Pi is a reference to the Python programming language. The first model of Raspberry Pi was released on February 2012 by Raspberry Pi Foundation in association with Broadcom. It's a single board computer, which typically means that a computer built on a single circuit board with microprocessors, memory components, inputs, outputs, and various other features required in a functional computer. The Raspberry Pi board comprises a program memory, processor, graphics chip, CPU, GPU, then Ethernet port, GPIO pins, USB ports, and a power source connector. It also has various interfaces for connecting to external devices. Raspberry Pi board boots from a SD card similar to a PC, which boots up from its hard drive. Almost each release comes in two models, Model A and Model B. Model A is a hardware reduced version of Model B, so many tasks which would be possible with Model B will not be with Model A. And therefore, Model A board will consume less power and is also cheaper than Model B. The choice of model would depend on the task and somewhat our budget as well. The Raspberry Pi Foundation provides Raspberry Pi OS, which was formerly called Raspbian, which is a Debian-based Linux distribution. They also provide third-party Ubuntu, Windows, RISC OS, and specialized distributions for the Kodi Media Center and classroom management. They promote Python and Scratch as the main programming language, with support for many other languages as well. Alright, with that in mind, let's talk about the real-world applications where it's used. First of all, it's an excellent tool for teaching coding, electronics, and robotics to students of all ages. Students can create small projects, and along the way, they can learn several interesting things about a computer, its working, and the applications in real world. It's also used extensively for the purpose of home automation as an application of IoT, Internet of Things. The general idea is that circuit receives the command by connecting to internet using Wi-Fi connector, and then the Raspberry Pi processor processes these commands, which then sends appropriate instructions to the connected devices. It can operate the loads for switching them on or off according to the desired user commands, or perform some function as per user's instructions. This is a very high-level explanation about how we automate home appliances over internet using Raspberry Pi, but we will explore more about this in other videos of this playlist. Raspberry Pi boards are also used in many industrial applications. For example, Raspberry Pi modules can form the basis of I/O and sensor modules, as well as control and server units. They are used for tracking and data monitoring purposes and are ideal for 3D printing and just-in-time manufacturing. Raspberry Pi computers are excellent tools for building prototypes and proof of concept solutions, which are useful for validating ideas in the industry and not only for people looking to develop new products. There are several startups which use Raspberry Pi as a base for building their own products. Along with all of this, any person can leverage the vast amount of resources present on internet to learn about Raspberry Pi and make projects of their own. And I'm one such example. There could be thousands of people on YouTube which do similar thing. These were just some of the uses of Raspberry Pi to give you an idea of where and how you can use it. Okay, now I'm going to show you a huge table which will say a lot about various releases from Raspberry Pi Foundation along with the specifications. There is no need to get overwhelmed. You can always pause the video and have a look at the table. But I won't be going through all of it because we will discuss about the hardware components of Raspberry Pi 4B model after some time in slightly more detail. So here it is. This table has almost all the models from the beginning of Raspberry Pi to the latest one. You can have a look at various specs here, and if you want to have a closer look, please pause the video. We have been talking a lot about single board computers. So moving ahead, let's also brush up a little on single board computers. Here are some of the examples of SBCs: Raspberry Pi, NanoPi, and BeagleBoard. All are single board computers from different organizations, but the underlying concepts are similar. A single board computer is a complete computer built on a single circuit board with microprocessors, memory, input-output ports, and other features required of a functional computer. Unlike a desktop personal computer, SPCs often do not rely on expansion slots for peripheral functions. They're commonly made as demonstration or development systems for educational purposes or for use as embedded computer controllers. Many types of home computers or portable computers integrate all their functions onto a single PCB. SPCs were made possible by increasing the density of integrated circuits. A single board configuration reduces the overall cost of system by reducing the number of circuit boards required and by eliminating connectors and bus driver circuits that would otherwise be required in a multi-board computer. SPCs are most commonly used in industrial situations where they are used in rack mount format for process control or embedded within other devices to provide control and interfacing. They are used in deep sea exploration and in outer space as well. Because of very high levels of integration, reduced component counts, and reduced connector counts, SPCs are often smaller, lighter, more power efficient, and more reliable than comparable multi-board computers. And these have been designed in various standard form factors. They have been built around various internal processing structures, including the Intel architecture, multiprocessing architecture, and low-power processing systems like RISC and SPARC. Finally, let's study about hardware components in Raspberry Pi 4B model. This model was released on 21st of June in 2019. This slide shows all the measurements of 4B model. I have highlighted the measurements which will be required while mounting this model. All the measurements are in millimeters. If you want to continue looking at it, please pause the video. Otherwise, let's move ahead. The processor in Raspberry Pi 4B model is the Broadcom BCM2711 chip, which is built in 28 nanometer technology and has a 64 bits wide data bus. It has a quad-core Cortex A72 core with a clock speed of 1.5 GHz. It has a Video Core 6 GPU handling all the graphical input-output work. This processor has been designed to cope with 4K resolution and H.265 video, as well as video scaling, camera input, and all HDMI and composite video outputs. It's a really heavy processor. This board contains LPDDR4 SDRAM memory, which is low power, double data rate, synchronous dynamic random access memory, which indicates that it consumes less energy and has more power saving capabilities than prior generations of RAM. It can process up to 33 GB of data per second by reading and writing 8 bytes of data twice per CPU clock cycle. It also has a super speed USB 3.0 host controller IC, VIA-VL805. This chip enables a PCIe-equipped platform to interface with USB super speed, high speed, full speed, and low speed devices. In-house, USB PHY employs advanced CMOS process to reduce power consumption. This chip is fully backward compatible with USB 2.0 and 1.1 specifications, which ensures seamless connectivity of legacy USB devices also. VL805 has a PCIe 2.0 interface, which is backwards compatible with PCIe 1.0 and is perfectly suited for both PC host and add-in card applications. Raspberry Pi Model 4B also has Gigabit Ethernet PHY card on its board, which is PCM54213PE. This chip from Broadcom is a triple speed 1000 base T, 100 base TX, 10 base T Gigabit Ethernet transceiver integrated into a single chip. It performs all physical layer functions for all these three speeds on standard category 5 UTP cable. It combines digital adaptive equalizers, ADCs, PLLs, encoders, decoders, echo cancellers, crosstalk cancellers, and all required support circuitry as well. This port also has a dual band Wi-Fi that can run on 2.4 and 5 GHz frequencies. It also has Bluetooth 5.0, which can connect to your device even if you are 800 feet away from the board, and it allows connected devices to use speeds of up to 2 Mbps. Bluetooth 5 has enough bandwidth at 2 Mbps to support two sets of wireless devices simultaneously. And this is backward compatible with Bluetooth 4, 4.1 and 4.2. There are two slots for USB 3.0, two slots for USB 2. It also has standard 40-pin GPIO header, which is backwards compatible with previous ports, and a Gigabit Ethernet port. The board also has two micro HDMI ports which support 4K displays. It has a 2-lane MIPI display serial interface DisplayPort, which was designed to interface today's cell phones and smartphones displays and is the most common connection interface these days. It uses low voltage differential signaling over a D-PHY layer to communicate with the display over 2 or 4 data pairs. In addition to the data lines, the MIPI interface also has a differential clock pair that times the signals at a very high frequency. The range of data transmission of MIPI D-PHY layer is 8 Mbps to 2.5 Gbps. It also has a 2-lane MIPI camera serial interface camera port. It's a widely adopted high-speed protocol for transmission of still and video images from image sensors to application processors. There is a 4-pole stereo audio and composite video port which has 4 conductors, which are tip, 2 rings and a sleeve. Hence it's a TRRS kind of port. The Pi models B+, 2, 3 and 4 all have a 4-pole 3.5mm jack, which also includes the composite video signal. This has allowed for the removal of the composite video socket found on the original Model B. The 4 conductors are sleeve, which carries video signal, ring 2, which is grounded, ring 1, which carries right audio, and the tip for left audio. And finally, there is a micro SD card slot. SD stands for Secure Digital, by the way. The micro SD card that we can insert into this slot will contain an operating system, and it is also used for data storage. So that's all about the hardware components in Raspberry Pi Model 4B. Before logging off, I should tell you that this model comes in different variants, which differ in the amount of memory. There is a 2 GB version, a 4 GB and an 8 GB version also. This is all I had for this video. In upcoming weeks, I will be making more such videos for this playlist. So make sure you like, subscribe and press the bell icon for getting regular updates. And also don't forget to give your suggestions in the comment section. Thank you and have a good day.